Okay, so this is another hardware example problem, similar to the first one we did. It has a RAM in it. Okay, so we went over this before, and kind of in two parts, and I need to go over it in two parts also, because once again YouTube is not going to let me post videos that are that long. So essentially what I'm going to do here is kind of talk about it, and then I will, in the next video, I will go actually solve the problem. So essentially what I want is to design a circuit that looks at the data in a 16x8 RAM. It tries to see how many values are equal to 47. Essentially it counts how many values are equal to 47, and it displays that count. Now, so the first thing, similar to the last problem here, is we have a RAM. What we know about RAMs is we have one way to address them. That's going to be the output of a decoder, output of a counter. So this is a 16x8 RAM. It has 16 chunks of things in it. I need to drive this, or drive the address, with a 4-bit counter. So I need a 4-bit counter. I need a RAM, and while looking through this thing, it's counting up to 16, right? It could possibly be that every single address in this RAM, every single piece of data in this RAM is 47. That could be 16 things. So don't get thinking that it's 4 bits. Remember, with 4 bits, I can only represent 15 things at most. The range for 4 bits is 0 through 15. So the output of this thing, output of the circuit, is going to be a 5-bit value. So this value is going to be persistent. So essentially what's going to happen in the circuit is I'm going to get a go signal. Sometimes I use a button. Get a go signal and start counting the number of values in that RAM that are equal to this hex number 47. Now this is the notion in these problems are that some external device has pre-written the values to the RAM, and nothing in this problem requires me to do any writes in this thing. So effectively I can turn the write enable off. And so typically I just ground it, but it's probably better to put it into state diagram. And I'm trying to think of what else in here. Yeah, so the most important thing is when you look at these problems, kind of get a feel for the output. Certainly the signal widths and the outputs are something that's really never specified in these things. I don't want to use any weird circuits on this thing. I want to use standard digital circuits. And it is a state machine, so I do have to come out with a state diagram before I'm done on this thing. And lastly, what else is interesting in this thing? And I suddenly reading through this problem, I realized I forgot to do part of the last problem, and that's really the starting point for any of these problems. I think I'm going to go ahead and draw that here because I can, and then it'll save me time in the next problem. So I'm going to try to figure out what's going on in this problem, and I'm going to do that by just writing the high-level interface on this thing. Okay, so we agreed that it has a 5-bit count on this thing, and so there's my 5-bit output. Certainly it has a go signal, and it has a clock, and other than that, I think I'm done with this high-level interface. This should always be the first step in any problem you do. Like I said, I realized I forgot to do it in the last problem. And I think with that, I think we've said all we can about this. I think we're ready to design the circuit once again. Once again, this is going to need a RAM and a counter to drive the RAM. Oh, what else do we need in this thing? Certainly it's going to need a counter to count the number of occurrences of 47, and that's going to be a 5-bit. Sure, and this is going to be a 4-bit counter because I only need to do 16 different things, and this problem, if you look at the problem, there's only one way I can do this. This counter is going to essentially be an event counter that I'm going to count up, increment it anytime I find a 47, but what's going to help me find a 47 here is going to be a comparator. Okay, and to make all these things work together, I'm going to need a state machine on this thing. And when I'm done, I will have, what, 1, 2, 3, 4, 5 circuits here, 5 modules, and I will kick out a state diagram which will finish off the problem. Okay, so let's restart this thing in a new video and get it done.